Hi, did you know EDEXCEL made practice papers? Well, they do, and they're a fantastic resource. They are full sets, papers 1, 2, and 3, and 80 marks on each. So, how many have they actually made? Loads. I mean, loads. There are 144. I don't think anybody would need that many. Anyway, I am making it my mission to do worked solutions for as many as I can. Obviously, the goal is all 144. I do work full time though, so I'm going to be creating them and pushing them out as quickly as I can. So watch the channel because new videos are going to land all the time. Now, to use the papers, I would recommend downloading them, sitting quietly, cracking on with it, and then coming back to do the marking. You've got all the solutions with walkthrough examples. So if anything's gone wrong and you need to see the steps and the methods, it's all going to be there for you. Now, for grade boundaries on the end screen, I've provided some percentages as guide only. No one knows what the grade boundaries will be ever. Anyone telling you are really just trying to give you a guide, and mine is no different. I have gone for the highest percentages we've seen so that we are reducing our risks, but it gives you a goal. It gives you something to head for. And I think that is really, really useful. So once you've got your score, check out the end screen, and that will also give you an idea of your grade. Now, if you're really struggling, if you're finding that you're sitting down to do the papers and they're not going very well, but you like the way that I explain and walk through the questions, then I do have some courses that are available. They are in the description below, so you can just click on that link. If you are somebody that wants to be studying and gaining the higher grades, my grade 6 course is currently free here on the channel. So do go and check that out. The course is designed to help you develop your critical thinking skills. So whilst it's all labeled up as grade 6, because we use a lot of those topics to help us, actually what you're going to really get from that is those topics, but the critical skills that you need. Okay, well, good luck with your studies. This will make a great addition to your revision. If you like what we're doing, please hit that like and subscribe button. That'll hopefully push the video out to more people and more people can benefit from it. Obviously, comments are great. So yeah, just good luck. Revising for a GCSE maths, it's going to be tough. So I wish you well. Okay, so we've been given some information about area and pressure, and we need to find the force. So we've got our formula. The force has been given as 28 newtons per meter squared, and the area is 1500 centimeters squared. And this is the first problem, and the first thing we really want to pick up in this question. We have different units, and they cannot be different. We're going to change our centimeters squared into meters squared. So let's just consider the area of a 1 meter square. Both the edges would be 1 meter. Now, if we took that same square and we wrote the equivalent centimeters on and worked that out, 100 times 100, and we can see 1 meter squared, 1 times 1 is 1 meter, 1 meter square is equal to 10,000 centimeters squared. That's our conversion rate. Most people, if they're going to go wrong, are probably going to divide by 100 because there's 100 centimeters in a meter. But we're not talking about the length, we're talking about the area, the space inside. So we are going to have to take our 1500 in the question, divide it through by our 10,000 to get our area in meters. Now that I've got the same units, I can literally just say, okay, my pressure is 28. That equals the force, which I don't know, divided by an area of 0.15. To work out the force, I just want to multiply through. So 28 times 0.15 gives a final answer of 4.2 newtons. Okay, so we've got candles that are being sold in packets of different sizes, and we've got the information about that. We want to make sure that all the candles bought are used, and we need to work out the smallest number of packets of each type that needs to be bought. Now, the first thing we need to do is work out the lowest common multiple. So we could list the 25 times table, we could list the 12, we could list the 8s until we find a match. I'm going to show a slightly different way of approaching this by doing the product of prime factors. So for 25, I have 5 and 5. For 12, I would have 2 and 6, and then 2 and 3. So I'll just circle my actual prime factors. And for 8, I would have 2 and 4, 2 and 2. Now, what I'm going to do is I'm going to put these into a Venn diagram so that I can see what my lowest common multiple will be. Make sure you do some decent overlapping. I'm just labeling up the circles. Now, if I look at my 25, the prime factors are 5 and 5. 5 doesn't come up as prime factors in any of the others, so they will just go into that section. We don't want it overlapping into any of the other circles. Now, 12 and 8 share 2. So 12 and 8 share 2. They share another 2. And then 12 has 3, 8 has 2. And then you multiply everything in the Venn diagram, which gives 600. Now, I've got to work out how many packets. So I'm just going to divide through. There's 25 white candles in a packet. So 600 divided by 25 means we need 24 white. 600 divided by 12 gives me 50. So we need 50 silver. And 600 divided by 8 is 75. So 75 gold. Okay, so how many sets of candles can we make from these packets? We may need to go back up and just refer to what he's actually doing. In this part of the question, he puts a white candle, a silver candle, and a gold. So he's putting one of each in to make the set. If he's using one of each, means he can make 600. Okay, we have a square with length 8.4, and we've got to work out the length of the diagonal. I'm going to put that diagonal in so that I can see it. I could have done it this way. It makes no difference. And I can see that this is a sneaky little Pythag. This edge is also 8.4. My right angle is here. A squared plus B squared equals C squared. You can get that off the formula sheet if you are a student taking their exam in 25, 26, or 27. A and B are the two edges that the right angle points to. And it's a really nice, neat way of just knowing what numbers to put where. So I've got 8.4 squared plus 8.4 squared equaling my diagonal, which is C squared. This gives me 141, and then we just square root to get our final answer. Now, it wants it correct to 3 significant figures, so it means it's going to get cut here. And the 7 is 5 or more to give a final answer of 11.9. So we've got red and blue counters in a box. There are 3 times as many red counters as there are blue counters. Carl is going to take a third of the red counters. Kerry takes 80% of the blue. And we've got to work out the ratio of the number that are left in the box. So the first thing we really need to do is get our ratios together on this one. We've got just red and blue. We know that there are 3 times as many red as there are blue. So let's just say there is 1 blue. If there's 3 times as many, that's going to give us 3 to 1 as a ratio. We know that there are 120 in total. Well, the total for the ratio is 4. 120 in total for the question. To get from 4 to 120, I would times by 30. So that's kind of like the magic multiplication that we need. That's going to give us 90 red and 30 blue. A third of red, so a third of 90 were taken by Carl. Now we just need to divide by the bottom, but equally it is a calculator question, so you can just throw it in there and you will get 30. 80% of 30. Again, you can just put that straight into your calculator. You can use the percent symbol and the times sign, or you can find 10%, which is 3, times it up by 8, which is 24. So lots of different ways to process that. So 30 red have gone, 24 blue have gone. So I'm going to take off the 30, take off the 24, and that is going to give me 60 ... 6 for my red and my blue that are left. Okay, so these are what's left. Now it wants the ratio in its simplest form. So we're just going to divide through by 6, and that is going to give us 10.1 as our final answer. Okay, so the diagram shows a circular pond with a path around it. The pond has a radius of 5 and the path has a width of just 1 meter, and we've got to work out the area of the path. Now, what's actually happening here, and I want you to try your best to imagine this. This here is a large circle. So let's draw this large circle. It has a radius all the way to the middle of 6. Now, this very large circle has kind of had a hole punched out of it. So imagine this being just punched out and creating a hole. So this smaller circle with a radius of 5 is punched out. So we want the area, which is pi r squared, of this, take away the area, pi r squared, of this. Now, again, if you are taking your exam in 25, 26, 27, these formulas are on the formula sheet, so you are able to use them. So we've got pi times 6 squared, which is 36 pi, take away pi times 5 squared, which is 25 pi. Now, you can go into decimals at this stage, or you can just leave it in pi. 36 take 25 is 11 pi. You could then put your 11 pi into your calculator, which will give you 34.55, and on it goes. We want 3 sig fig, so count 3 and cut. 5 is big enough to add 1, so we've got 34.6 meters squared as our final answer. Okay, so we're being told that the total cost of 3 apples and 4 pears is £1.84, and then we've got more information about a different combination. Now, this is a sneaky simultaneous equation. It's just been given to you in words instead of in the normal format that you are used to. So what we've got are 3 apples plus 4 pears equaling £1.84. And we've got 5 apples plus 2 pears equaling £1.76. And when you see it written like that, you can see the simultaneous equations. Now, don't be put off by the decimals. You've got a calculator. So as long as you're really confident with your method, you just step through in the normal way. Now, if you're one of my students, you'll know that I'm always saying just get these the same. 95% of the time, that is going to be easier in the long run. So I am going to multiply the top one by 5, the bottom one by 3. We're going to multiply all the terms and get equivalent equations to work on. Once I've done that, I'm going to be taking away my A's from each other, my P's from each other, and my numbers from each other. Now, 15A take 15A means the A's have gone. That's the point of the method. We don't really want to be trying to work out 2 different letters at the same time. So my A's have vanished. I've now got 20p take 6p, which is 14p. That equals £3.92. I'm going to divide through by my 14 and work out that p is equal to 0.28 or 28 pence, because they do want our final answer in pence. Now I know my p, I can work out my a. I need to choose one of these. I think I'm going to go for this one. So I've got 5a plus 2p equaling £1.76. This is going to be 2 times 0.28. I'm going to use my decimal answer because I'm still working within these calculations. So this is going to give me 5a plus 0.56 equaling £1.76. And now I will just go on and solve. I'm going to take this across. It lands is take away 0.56. So 5a is equal to 1.2. Divide through by the 5, and a is equal to 0.24 or 24 pence for the answer line. Okay, so we've got a right angled triangle and we're being asked to find the angle marked X. So this is a trig and we have got our formula sheet to help us with that. So do make sure you use it. The formula sheet does not use SOHCAHTOA. It uses A, B, and C. So that's what I'm going to do. Please remember that at the stage of this video being made, it was 2025, 26, 27, where it was guaranteed for that formula sheet to be available. Hopefully, they'll just keep it in place forever. Anyway, the given angle that we have to find, opposite is our A, and then I use the right angle. Once I've got A on one, B is on the other edge that the right angle points to, and this would be my C. I don't need C, it doesn't have any information on it. I would then look at my formula sheet and see which one of sine, cos, or tan has the A and B, and it is tan. And it looks like that on the formula sheet, which works really well with this question. But I would still encourage popping it into the triangle, because if it's a different style question, this can really make a difference and help you see what you need to do. So we've got tan, the capital A is our angle, which we don't know. A is 14, B is 7.5. If I want to know what my angle is, I need to get it on its own. So we're going to move the tan across the equals. So my A or my X, I could have changed to X by now. That's the opposite of tan. Put it in your calculator and then just check to see how they want us to round. It's to the nearest degree. So this would be 62 degrees. Okay, so there's quite a lot going on in this question. It is a 6-mark question, so you know that there's a lot going on when they're going to award 6 marks. We've got to ultimately work out the area of badge A. They're telling us that the perimeter of badge A and badge B are equal. So the perimeter is what is going to help us eventually work out what they want us to work out. And of course, everything is in algebra. Now, perimeter doesn't change its meaning. It means all the edges added together. So that's the first thing that we're going to take a little look at. So if we look at the trapezium, I've got X, 3X, 3X, and 3X on the edges. So the total number of X's I've got is 10X. And then if I check in with the numbers, I've got 1 plus another one, which is 2. But then it tells me to take 2 away. So my numbers will cancel out, and the perimeter of my trapezium will just be 10x. The perimeter of the rectangle, and be careful, it's so easy to forget these edges because they don't have anything marked on them. So be careful for that. Now, all the x's add to 12x, and then I've got minus 5, and they're saying take another 3 away. That'll take me to negative 8. And then this is a repeat, so that's another negative 8. I will end up at minus 16. The perimeters are equal, so 12x minus 16 equals 10x. I need to solve this equation. I'm going to bring the x's together. And don't be fearful that you're leaving nothing on this side. It doesn't matter. Just move the smaller set. It'll land as a take. And by moving the smaller set, I've avoided negative numbers. So I've got 2x minus 16, the moment equaling nothing. But of course, as soon as I then start getting to work on getting x on its own, the minus 16 is going to land as plus 16. You can see it's all coming out just fine. Divide through by 2, and my x is equal to 8. Now, the area of a trapezium is on the formula sheet. Half A plus B times height. So that's what it will look like. A and B are your parallel sides. The height is the distance between them. So we've got a half times x plus 3x minus 2 times 24. Now, you could have already substituted your x in and found values. There's no right or wrong way here. I'm just doing it this way. So I've got 4x minus 2 in that bracket. I know that my x is 8. 4 8s are 32. Take off the 2 and I've got 30. So what I've now got is a half of 30 times 24. That's going to lead to 15 times 24. And the final answer would be 360. I'm showing more than I really need to. Remember, this is a calculator paper. Once you've got your numbers, you can throw it straight in your calculator and get here. You don't need to split it through, okay? Okay, so we've got to find the size of angle marked X, and we've got to give reasons. Now, I would always recommend doing the reasons as you go, and then you can't forget what you did. So I want to find X. If I knew this one here, I could just do angles on a straight line, but I don't know that one. I can see by looking at the diagram that I've got these dashes. So these dashes are on these edges here, which tells me I have an isosceles triangle within this diagram. I've also got these arrows, which means that I have parallel lines. They've given me 65. It's attached to the parallel line, and this one bringing it down to this parallel line. So that's where I am going to start. You can see the X shape that creates. Alternate angles is what I'm using, and alternate angles are equal. Now I can use the fact that the triangle is isosceles. I have an angle. Which two are the same? It's really tempting for a lot of students to make it the base and not think any deeper than that. I want you to consider the edges. If we go from this point here away, you can see that my light is going to 2 angles. Whereas if I went from this point and went forwards, it's going to 1. When it comes together to the 1, that's the different angle. When you go away to the 2, they're the ones that are the same. So I now know that is 65 as well. And the reason is it's an isosceles triangle. I can now find this one using angles in a triangle. So 180, take away 130. That's my 2 65s. That equals 50 degrees. And I used angles in triangle equals 180. And then finishing it on there as a straight line with that 50 degrees. So writing as you go means you don't have to think about it later. And you'll notice that I'm writing everything onto my diagram. It's really helpful to see the angles you're finding within the diagram. Okay, so we're looking at a clock. We've been given all the information that we can see in the diagram. We've got to calculate the length of AB when it's showing 5 o'clock, which is all set up to do for us. So we want to be working out this edge here. It's a triangle. It is not right angled. We have these 2 edges and we want to find this. If we had this angle, then we could be using the cosine rule. It is a 360-degree circle that's been perfectly split into 12 sections for the 12 hours. So if I do 360 and divide that by 12, will give me 30 degrees. So each section is 30. I have 1, 2, 3, 4, 5 sections. So my angle is 150 degrees. I now have everything I need to use the cosine rule. First thing you should do is copy it down from your formula sheet so it's nice and clear on your exam page. Okay, now when we're using this formula, you'll notice that we've got an A at the very beginning and an A at the very end. The capital A is our angle, and this is one of our edges. So we know, because we have this angle, that our edge we're wanting to find is AB. So it's all set up perfect, ready for us to go. It doesn't matter which way round the 10 and the 7 is used in the B and the C. So the first thing we need to do is substitute in all the information. And then we can start using our calculator. Now, I wouldn't throw it all in one go. I would never risk it. It doesn't always work out. So I'm going to do my 10 squared plus my 7 squared, which is nice and simple. And then I'm going to work through, using my calculator, this section here. And that has come out as minus 121.243. On and on it goes. A squared is equal to 149 minus the answer. Use your answer key. I'm really doing that to try and drum that home. It's so helpful. Don't round halfway through. Use your answer key. That is giving me 270.243 and on it goes. And then I just need to square root that answer to get my A. It says 3 sig fig, so we'd cut it here. The 3 isn't big enough to change anything, so the final answer is 16.4 centimeters. Okay, so we have a cumulative frequency question. They've already done the cumulative frequency for us, so we don't need to add as we go. That's been done, and you can tell that because we've gone from 0 to 20 and then 0 to 30, 0 to 40, and so on. We have to draw the graph. Just remember, it's the end point with the cumulative frequency that creates the coordinate. So 30, 70, and so on. Make sure you are plotting with accuracy. So for example, our first one, 2025, if I just zoom in, our 25 will be here. So our 2025, you want to mark it on as accurately as possible. Once you've marked on all of your coordinates, you want to draw as smooth a curve as you can. So that's mine. It's a little bit wobbly in places. I've tried to get to all the points. And remember, you must stretch it down to that minimum value. In this case, it's 0. It's not always 0, so don't make it an automatic, I go to the corner of the graph type thing. Do check in, and that's good enough. It doesn't matter if it's got a little wobble in it. What matters is it doesn't have any straight lines in it, so don't be tempted to do that. Okay, now part B of the question, we've got Graham saying that 10% of workers at the factory are older than 65. Using the maths, 10% would be 20, which would be 180 to 200 being over 65. Using the graph, and what we're going to do to use the graph is we're going to go to that 65, again, be as accurate as you can be. We're going to go straight up, hit the graph, and then we're going to come across. Once we've got that marked on the graph, we can see that the graph is telling us it's starting at 190, not 180. So the graph is just showing us 5%, and that's what we would write down. Or words to that effect. So that was part B answered. The mark could also be given for 4.5% or 7% as well. So if you did get 4.5 or 7, just be mindful that that would have been an acceptable answer too. Okay, so we've got a percent, we've got a decrease. That means this is the original times multiplier equals result. When a number is reduced by 30%, so my multiplier will be 0.7, the answer 17,920. So it's the original that I don't know, that number. All I've got to do is divide through by that 0.7. And that's the answer. Okay, so we've got biscuits and sweets, and Michael is taking a biscuit and a sweet randomly. And we got to work out the probability that either the biscuit is mint or the sweet is mint, but not both. Well, we've got our keyword probability. This is going to be a tree diagram because we want to see all the possible outcomes. So my first section that I'm going to draw is all about the biscuits. I've got 4 out of 5 that are mint, and I've got 1 out of 5 that is toffee. And then I'm going to build in my sweet information on the second set of branches. So we've got mint, sweets, and strawberry. Just keep the logical order going. And we've got 5 out of 8 being repeated across that diagram. Now let's remind ourselves, we've got to work out the probability that either the biscuit is mint or the sweet is mint, but not both. So this is the biscuit being mint, and that's making sure it's not both. And then you've got your toffee biscuit and your mint sweet. So those are our 2 pathways. We're going to collect up the fractions from both those pathways. This gives 12 over 40 and 5 over 40. Now, when you've got 2 results, you just add those together. So 12 plus 5 is 17, and you've got 17 over 40 as your final answer. Okay, we've got a trapezium, and we've got to show that question. At the end of the working out that we do, we should have something that looks identical to this. Show that's a great, because it really is just telling you the answer. It says the area of the trapezium is 46. So let's think about that formula. We saw it earlier. It's a half A plus B times the height. That is the formula to find the area. Now we're going to pop in the bits that we know. So we've got a half. Now A and B are the parallel edges. So I'm going to do this before I write it down. So I've got 3 x's plus another 5 x's. I have got 8 x's, and then adding my numbers, I've got plus 4, and then that would get multiplied through by the height, which is 2x plus 3. We know this is equal to 46. So that's all the detail. That's everything that I want. Now I am going to concentrate on expanding these brackets. I'm going to make that my first job. So we've got a half 16x squared plus 32x plus 12, which will equal 46. So let's do this halving. Let's just half all these terms, and then that sorts the half step out. We've got 8x squared plus 16x plus 6 equaling 46. I'm going to bring this across so that it equals the 0. We want quadratics to equal 0, and we can see here in the question that they want it to equal 0. So let's get that step done. And then we've got 8x squared plus 16x minus 40 equaling 0. We just need to cancel by 8 to bring everything to the answer. X squared plus 2x minus 5 equals 0. Okay, so we've got to now solve the equation, and we've got to give our solutions correct to 2 decimal places. Well, that's the biggest clue ever, that this is going to be the quadratic formula. The quadratic formula is on the formula sheet, so please use that. Copy it down so that you've got it as a reference on your exam page. I can see my values of A, B, and C from the question itself. So A is 1, B is positive 2, C is negative 5. And now I can just substitute all those values into my formula. Tidy this up. I would always be really careful about doing the whole thing in one go on my calculator. I just wouldn't do it. So we've got minus 2 plus or minus the root of 24 all over 2. And now we're going to split this so that we've got 2 solutions. We've got minus 2 plus root 24 over 2, and we've got minus 2 minus root 24 over 2. And now just throw that in your calculator. You will get 1.4494 and minus 3.449. It wants it to 2 decimal places. So on the dotted line, you would be putting, and I'm not going to do it on the dotted line because I'm already on top of it virtually. I'll do it over here, 1.45 and minus 3.45. And that would be your final answer. Okay, so the graph of G is a translation of the graph of y equals fx. So let's just take a look at our diagram. Y equals f of x is here, and then you've got your graph G here. So we can see that f of x has moved horizontally forward 5 places. If you use a coordinate to help you, you can see that count. 1, 2, 3, 4, 5. Now, it's the x coordinate that gets affected on a horizontal movement. And again, if I just highlight that by showing you that this one has gone from being -2, -1.5 to 3, -1.5, you can see how that y coordinate is exactly the same. Now, if it's the x coordinate that's being affected, then the change in the equation, the way that you're going to represent the equation in terms of f, requires you to make sure that you're in with the x. And I'll show you what I mean by that by doing the opposite in a moment. So we would have y equals f x minus 5. It feels alien to write that because we've moved forward, which is in the positive direction, but an x movement will always be represented in its equation with the opposite sign and always tucked in with the x. If you wrote it on the outside, so f x, and then put your -5, you have just written something that creates a vertical movement, not a horizontal. So that would be completely wrong and absolutely no marks. So if it's a horizontal translation, in with the x, tucked in the same bracket together. Okay, so y equals f of x has a maximum point at -4, 3. And now we are being told that we've got y equals f and it's -x. Now remember what I just said. If it's tucked in with the x, then it's the x coordinate that gets affected. It's also the opposite of what we see. So we're seeing times by -1 in that bracket. The opposite would be to divide by -1. So if I've got my x coordinate and I divide it by -1, it will give me 4. So the answer is 4, 3. What's actually happening to the whole graph is it's flipping in the y-axis as a reflection. Okay, we're going to prove algebraically that x can be written as 1/66. So x is technically, at this stage in my question, a fraction I don't know. So the fraction that I don't know is equal to 0.01515, and on it goes. And I've just got rid of those dots and seen a little bit of my recurring decimal. I can see that it takes 2 places for a number to recur. That tells me to multiply the whole thing by 100. If I do that, I get this. The next step is always the same, just take away an x, and we know that x is equal to 0.01515, And if we've done it right, we will get numbers sitting on top of each other, and these numbers will just cancel out. So all of that has gone. So it no longer recurs into infinity with this method. We end up with 99x terminating at 1.5. Now we're going to divide through by the 99 to get x on its own. We are going to times through by 10 to sort out the decimal. And then remember, we are on a calculator paper. At this stage, I would be putting that into my calculator and making absolutely sure it cancelled to that result that they wanted. And there you go, we've shown it. Okay, p is inversely proportional to the square of x. So we're going to set up an equation with that constant of proportionality. Because it's inversely proportional, it will be k over x squared. That's the square of x. If it was directly, it would be multiplying to x squared. I'm going to substitute in the information that they've given me. So p is 6. That's my constant of proportionality, which I'm going to work out using the numbers that they've given me. So I'm going to end up with 6 times 25, which is going to give me 150. So K is equal to 150. Once I've got that, I can substitute it in. That's the constant. That's there in every question. I've now got an equation that I can use to finish it off with. So P is equal to 150. X is 8, which is 8 squared. So I've now got 150 over 64. Put that in your calculator and you're getting P equals 2.34. On and on it goes. Check in with your question. 2 decimal places cuts it here. So 2.34 is the final answer. Okay, so we've got a graph where we're being asked to estimate the rate of change of the velocity at a particular time. Now, a particular time actually just generates, and I'm going to just zoom in a little bit now. It just generates a single coordinate, and we can't work out a rate of change from a single coordinate. So what we're actually going to do is we're going to put on a tangent, and we want that tangent to touch it too. That way we will be able to create a triangle, which will enable us to do the rise over run, which is our rate of change. So let's go for it. I'm going to drop down my triangle at 3, and I'll leave it here. I won't bring it up like to be in line with the 2 and make a smaller triangle here. I'm just going to use this one big triangle. So I can see that my run is 1.8 and my rise is 20. I'm happy with that. This gives me a solution of 11.111, on and on it goes. So as it's an estimate, I will just say that it's 11.1 on my answer line. Now, everybody's tangent is going to be slightly different, and they allow for that. So there is quite a nice range of 9 to 14 for your answer. So as long as your answer falls between 9 and 14, all is good. You must have that tangent. You must have this working out as well. Okay, question 19. We're being told that a road is 4,530 meters long, correct to the nearest 10 meters. As soon as I read this correct to the nearest, I know I'm looking at a bounds question. They don't need to have that word necessarily in the story. It's definitely going to be bounds. And you can see we've got it again here. So the first thing that I'm going to do is work out my upper and lower bounds. Once you've got those, you can then get on with the rest of the question. If you're not sure how you would work out your bounds, think about using a number line. If we've been given 4,530 and it's rounded to the nearest 10, then it's a number line going up in tens, and your bounds are the midpoint between them. Okay, so that's how you would pull that together. The average speed limit for the road is 80. Could Kirsty's average speed have been greater than 80? Well, we've got the distance and we've got the time. Speed is equal to distance over time. I want to get the greatest result because I want to see if it could be greater than 80. In which case, I need to do the biggest divided by the smallest to create that greatest result. Okay, so that gives 22.395, but this is meters per second. Think about the units that we were given in the question, and we're being asked about whether or not it can be greater than 80 kilometers per hour. So I've now got to work on getting my units to kilometers per hour. So I've got meters per second. I will need to divide by 1,000 because I'm converting from meters into kilometers. And that is in 1 second. And now I'm going to times through by 60 to get it into a minute, and times through by 60 to get it into an hour. And when you multiply this, your calculator tells you 80.622. So yes, it could be over. Okay, we've got a quadratic sequence. First step is to look at the gaps. So we're going up 11, 15, and then 19. and then we've got gaps of 4 in the second row. Now remember that the second row gap must always be divided by 2 to get that coefficient in front of the n squared. So we've got 2n squared. I want my sequence to be 7, 18, 33, 52. I've got so far 2n squared. So I need to work out what those values actually are. When n is 1, I would get 2. When n is 2, I would get 8. When n is 3, I would get 18. 3 times 3 is 9, times by 2, 18. I don't need to do any more than that. Don't do any more work than necessary. Now I'm going to take what I've got away from what I want so that I can see the difference. So I am 5, 10, 15. That's what I am short of. I'm going to see this as a sequence. It's going up in 5s, which gives me 5n. I don't need to add or take from that. It is just 5n. So to create the sequence I want, I'm going to need 2n squared, and I'm going to need to add 5n squared to it. Okay, so we've been given two functions, gx and fx, and we've got to find the exact value of x when we've got the inverse. Notice how we've got that -1, the inverse of g equaling f of x. So the first thing that we're going to need to do is write the inverse. Instead of using g of x, we're going to use y. We are then going to swap the x and the y around. So y is going to become x, and x is going to become y. And now I want to rearrange what I've written so that I get y back on its own. So I'm going to have x, 3 minus y equaling 4y. I'm going to expand, and then I'm going to bring those y's so that they are together. I'm going to factorize the y out. I've still got my 3x on this side. And then I can just bring all of this across. Y is being multiplied to 4 plus x. So I can bring all of this across. And then I've got my 4 plus x landing as a divide. So the inverse is 3x over 4 plus x. So now we're going to set this up. It was the inverse function. So 3x over 4 plus x equaling f of x, which is 2x minus 5. So we're going to get rid of this divide, bring it across. It's going to land as times. So we want all of this to be multiplied by all of this. So we can see we've got ourselves a sneaky crab's claw, or however you expand your two brackets. I'm going to tidy all of this up, and I've put it in the order that I like. This 3x is going to come across, land as minus 3x, so that I end up with 2x squared minus 20 equaling 0. I'm going to cancel this down, divide through by 2 to give me x squared minus 10 equals 0. And then I've got x squared equals 10 square root. Now, x would equal plus or minus the square root of 10. I'm being told in the question that x will be greater than 3. So it cannot equal minus root 10. So the exact value is the positive root 10. And that's it, our last question. Another great practice paper with lots of different types of questions, which is really good to see. I hope the solutions have really helped, and you'll join us in more of these practice papers.